As we recall from our previous class, what is heat transfer? So heat transfer is thermal energy in transient due to spatial temperature difference. So today we are going to study about what are the different modes of heat transfer. So as we can see in this figure, so for conduction, so there are basically three modes of heat transfer. Heat transfer. So first is the which require material medium. Another modes of heat transfer which do not require any material medium. The mode of heat transfer which require material medium, if their material medium is stationary, and if that material medium is moving, if it is moving, then it is convection. And the heat transfer in the material medium which is stationary, it is conduction. So conduction is the mode of heat transfer through a solid, because solid is stationary generally, or any fluid, liquid or gas which is stationary and maintained at different temperatures at the two surfaces. And convection further can be classified into natural convection and forced convection. This category of convection heat transfer is the without phase change process. There is one more category of convection which is with phase change, which are nothing but boiling and condensation. These are the modes of convection heat transfer with phase change. And these processes are growing up like anything in the industry for cooling of various electronic equipments. And if in the absence of material medium, you can guess it is that heat transfer is nothing but the radiation. Radiation actually doesn't require any material medium. Any body, the philosophy of radiation is any body above absolute zero temperature will emit radiation in the form of electromagnetic waves, like sun is releasing heat that is reaching to the earth's surface, and in between there is vacuum and then atmosphere. So earth is receiving heat from the sun by virtue of radiation, and then conduction or convection through the atmosphere. And now we should understand each modes of this heat transfer in very detailed manner. So let's start with conduction. So if we can see here, these two surfaces are maintained at different temperatures, T1 and T2. T1 and T2, like it is shown here, and as T1 is greater than T2 and this material is solid and it is stationary, so heat will be transferred from this surface to this surface by mode of conduction. This is conduction heat transfer. And let's suppose this is the hot plate. Because surface temperature is greater than the fluid stream temperature. Fluid stream temperature, this is the undisturbed free stream temperature. Stream temperature, and let's say some fluid is moving over it. So when the fluid is moving over it, the first layer of the fluid which is in contact with the hot plate will come to at rest. And we know that when the material medium is at rest, so it will be transferring heat by conduction. So in the bottom layer from the hot surface, conduction happens, and after that above it fluid is moving, so that heat will be taken by the moving fluid to the downstream direction. So that heat that is taken by the moving fluid, because of its movement, it is advection. Okay, so conduction in the bottom layer and convection in the moving fluid is the result in convection. Conduction plus advection, which is nothing but bulk motion of fluid. Which is representing conduction heat transfer. So this results in convection. So convection, if we are using some external source to make the fluid moving over the hot surface, or so that is forced convection. If we are keeping hot plate inside the room, and because let's say if we are keeping the hot plate inside the room, and this is the room, let's say hot plate, so air will touch this hot plate, will get heated and rise. So the movement of the air is caused by the buoyancy effect, and it is self-driven, so it is natural convection or free convection, because we are not using an external force like fan or pump to make the fluid to move. And these are boiling and condensation, different other modes of heat transfer in the convection. Here we will see this in detail in the later. And radiation heat transfer is when two objects are, like we can see here, when two surfaces are kept at different temperature, and if we kept in vacuum these two surfaces will emit radiation in all the direction depending on their surface properties, and some amount of heat, some amount of energy will be intercepted by this surface, and some amount of energy will be intercepted by this surface. The net exchange result in the radiation heat transfer between the two surfaces. If the medium is present between the two surfaces, it will reduce the radiation. So presence of medium reduces the effect of radiation, while vacuum will enhance the radiation. So if we look into the mechanism of conduction heat transfer, in conduction heat transfer the mechanism is a random motion of particles. Random motion can be possible only for stationary gas. But if it is metal, then lattice vibration and movement of free electrons. It results in the conduction. Insulator don't have free electrons, so they have less thermal conductivity. No free electrons. So in solids, generally the conduction is because of the lattice vibration, movement of free electron. In insulators there are no free electrons, so no conduction and very poor conduction. So in conduction, high energy jetting molecule will transfer its energy to less energetic molecule. Like we can see here, these are two plates, plate 1, plate 2, which are maintained at temperature T1 and T2. And T1 is higher and T2 is higher, T2 is lower, and the molecule and there is stagnant air. So because the medium is stagnant, means stationary, so there will be conduction heat transfer between the two surfaces T1 and T2. The molecules of the air which are near to the hot surface will have higher energy, and the molecules which are farther from the hot plate will have less energy, and they are represented because of their color, means light red color is of the molecules which have less energy, and the dark red is having high energy. So high energetic molecules will transfer their energy to the less energetic molecules,